This is just going to be a quick run through of the Ford-Fulkerson algorithm to find the min, cut, and max flow of a directed graph. We're going to start out by finding a path from S to T. So we'll take, let's say, 10, 8, or this path from S to A to D, and D to T. So if we took that path, we would see that we had the lowest capacity amongst those is 8. And so we are going to initialize our algorithm by pushing 8 along that path. And all other values will start at 0. Once we've done that, we're now going to create a residual graph. And then for each edge in this residual path, we're going to check to see what the flow value is and what its capacity is. For a reverse edge, if there is any flow going through a path, then we're going to create a reverse edge with the value of that flow. And then, if the capacity minus the flow is greater than 0, we're going to create a forward edge with the result of that subtraction. So 10 minus 8 is 2. And we'll continue this for the remaining edges. So S to B, there is no flow, so we don't have a reverse edge, and then 10 minus the flow is still going to be 10. B to D is the same thing. Still have a capacity of 9 left. Is 2. A to C still has 4. And then for A to D, we have a flow of 8. So we will create a reverse edge, the value of 8. And then the flow minus the capacity is 0, so we don't need a forward edge. D to C has no flow, so it just has the forward edge with the value of 6. C to T just has the forward edge with the value still of 10. And D to T has a forward edge with a value of 2 because it has a capacity of 10 and a flow of 8. So 10 minus 8 is 2. And then it has a reverse edge, which will be the flow in our main graph from D to T, which was 8. Now we are simply going to find any path using any of these forward or reverse edges from S to T. So let's use another color. Let's say here we'll take this path from S to A to B, B to D, and D to T. Now, we are going to find the minimum capacity amongst the edges in this new path that we found. So we have 2, 2, 9, and 2. So the minimum capacity is 2. And with that, we are going to go back to our initial main graph. And for each one of those edges, we are going to increase the flow by 2 if the edge in our residual graph is a forward edge, and we are going to subtract 2 from the flow if the edge in that path on our residual graph was a reverse edge. So for example, S to A was a forward edge with a value of 2. So we are going to increase the edge from S to A in our main graph by 2, giving us a value of 10. A to B was a forward edge, so we are going to increase that value by 2. B to D was a forward edge, so we are going to increase that value by 2. And D to T was a forward edge, so we are going to increase that value by 2. Now we are again going to create another residual graph. And actually that's a really ugly 10 over here. Let's fix that. 10. And again, we are just drawing the forward and reverse edges in our residual graph. So now from S to A, we don't have a forward edge because the flow minus, or the capacity minus the flow is 0. But because we have a flow, we have a reverse edge with the value of the flow, which is 10. From A to B, we don't have an edge, but we do from B to A. We have a reverse edge there, value 2. A to C doesn't have a flow, so we have a forward edge of 4. For B to D, we have a reverse edge of value 2. And we have a forward edge of 9 minus 2, which is 7. C to D, we still just have a forward edge. For A to D, we just have the reverse edge of value 8. C to T has no flow, so it has no reverse edge. It just has a forward edge of the capacity minus the flow, which will be 10. And then D to T has a reverse edge of value 0 and no forward edge because the capacity of 10 minus the flow of 10 equals 0. Again, we will find another path through this. So this time we just need a path again from S to T using any of the forward or reverse edges. So we can go ahead and take, let's say, S to B, B to D, D to C, and C to T. And it looks like, I'm missing the forward value here from D to C, so that should be 6. Okay, and now that we have that path, we are going to take the smallest, the minimum capacity amongst the edges of that path, which in this case is going to be this 6 here. And we will go back to our main graph, and for each edge, if it's a forward edge, we are going to add 6. If it was a reverse edge, we are going to subtract 6. So 10, S to B was 0. Now S to B is going to have a flow of 6. B to D was 2, so it'll now have a value of 8. D to C was 0, so it'll have a value of 6. And C to T was 0, so it will have a value of 6. Again, we will create another residual graph. For S to B, we'll have a forward edge of 4, a reverse edge of 6, B to D, we will have a reverse edge of 8, and a forward edge of 1. For S to A, we will only have a reverse edge of 10. A to B, we won't have an edge. B to A, we will have that reverse edge there of 2. A to C doesn't have a flow, so it just has a forward edge of 4. For the A to D node, we have a flow of 8 and a capacity of 8, so we won't have a forward edge. We will just have that reverse edge, value 8. Now C to D, we're going to have that reverse edge of value 6 with no forward edge because 6 is the capacity. And for D and T, we'll have this reverse edge TD with a value of 10. And from C to T, we're going to have a reverse edge with the value of the flow, which is 6, and a forward edge with a value of 10 minus 6, which is 4. And once again, we will find another path from S to T in our new graph over here. So this time we can go from, I guess, S to B, and there's a path from B to D, and a path from D to A, and a path from A to C, and a path from C to T. The important thing to note here with these paths is your path can only go to each vector once. So I can't have a path where an edge starts from a node and then another edge ends up at that same node or that same vector. So now we have this new path. We'll look at it. We have 4, 1, 8, 4, and 4 as the capacities for those edges. So 1 there is obviously the minimum capacity of the edges that we used. So we're going to go back to our main graph and augment each of those edges with the value of 1. So we're going to do 6 plus 1 is 7. 8 plus 1 is 9. Now, from D to A, you'll notice that we followed a reverse edge, which means that instead of adding 1 to this edge on our main graph, we are going to subtract 1 from it. So now instead of having 8, we are going to have 7. From A to C, we followed that edge, so now instead of having a flow of 0, we'll have a flow of 1. And from C to T, instead of a flow of 6, we will have a flow of 7. Now that that's done, we will create another residual graph. we have a forward edge here of 3. A no forward edge from S to A. I'll do all the forward edges first. We have a forward edge from A to C, the value of 3. A forward edge from A to D now with a value of 1. A forward edge from C to T with a value of 3. And then all of our other edges are fully saturated with the flow, so those are just going to be the reverse edges of those capacities. So here we have a reverse edge of 10. This one we have a reverse edge of the flow with 7. This is 9. This is 10. This is 6. This is 2. This is 7. This is 1. And this is 7. Again, we'll find another path from S to T in our residual graph. This time we can take, let's say, this S to B, B to A, A to C, C to T. So amongst those, for the edges, we had 3, 2, 3, and 3. So 2 there is going to be our minimum capacity. We will go back. From S to B, we took a forward edge, so now we're going to have 7 plus 2, which will be 9. From B to A, we took a reverse edge. It was red, so we are going to subtract 2 from our current flow in the main graph, giving us 0. From A to C, we followed a forward edge, so we will increase the flow of 1 to 3. And from C to T, we followed a forward edge, so we'll increase 7 to 9. And that was the last edge in our path, so we will recreate. We will create another residual graph. S to B, we have a forward edge of 1. And a reverse edge of 9. From B to D, we have this reverse edge from D to B of 9. From A to S, we have a reverse edge, 10. A to C, well, C to A, we have this reverse edge, the value of 3. And a forward edge, the value of 1. From A to B, we now have a forward edge of value 2. From A to D, we have a forward edge with a value of 1 and a reverse edge from D to A with a value of 7. From D to C, we have a reverse edge of value 6. From T to D, we have this reverse edge of value 10. And from T to C, we have a reverse edge of value 9, and as well as a forward edge from C to T with a value of 1. Now, again, we are going to try and find a path from S to T. So we'll go from S to B, but now you'll notice that from after getting to B, we don't have any edges to follow from B. So if we circle the nodes that we got to here, we're going to call this set of vectors our set A, where now A equals the set containing S and B, and we'll say that B equals the set containing T and all of the other nodes, so A, C, and D. We're going to say that our minimum cut now is going to be this cut AB, and our maximum flow is going to be the sum of the edges leaving A. So if we circle this and we look at the edges that are leaving A, we have a flow of 10, and we have a flow of 9, and so the sum of those is going to give us our max flow of 19.